We are examining a corpus of 34 documents that proposes a specific numerical architecture. The dataset attempts to unify physical geography, chronological time, and linguistic ciphers into a single closed loop. These three domains typically lack a shared unit of measurement. Theoretically, a geographic coordinate and a line of text possess no mathematical crossover. To bridge this gap, the system isolates specific data points from three areas: geodetic space, chronological time, and linguistic strings. By reverse engineering this structure, we can observe the mechanics used to translate these disparate inputs into a unified integer lattice. This analysis explores the possibility of total informational closure, the point where different real-world datasets are forced into a self-consistent mathematical model. The process begins by assigning numerical values to language, turning words into state operators that can be used in an equation. Alphanumeric ciphers serve as the primary tool for this translation, mapping specific integer values to individual letters. Here, the system uses a Hebrew gematria cipher to parse the name Alex Campaign. By summing the values assigned to each character, such as 300 for X and 40 for N, it generates a fixed scalar of 470. The dataset applies different cipher standards to generate a range of primary identity scalars from names and titles. Through these ciphers, Alex Enrique Campaign is reduced to 188, while the Greek Iesus is assigned the value 888. Once language is reduced to absolute integers, it can be treated as a mathematical constraint within the broader matrix. To integrate geography, the system must convert map coordinates into the same flat integer format. The system anchors itself to two physical locations: Queen of Angels Hospital in Los Angeles and the Anastasis Rotunda in Jerusalem. By focusing on the center of the rotunda, the system establishes a precise geographic point to be partitioned into data tokens. The translation mechanic involves stripping the degrees, minutes, and seconds from a coordinate and treating the remaining strings as discrete numbers. For the rotunda, the system applies an additive reduction. The latitude tokens sum to 144, and the longitude tokens sum to 216. Combining these results establishes a spatial anchor of 360. Depending on which coordinate tokens are selected, this partitioning can produce different integer sums. While the hospital's coordinates can be reduced to a base sum of 270, other selections from the same location yield secondary scalars used later in the lattice. Adding the hospital's 270 sum to the rotunda's 360 sum establishes a combined spatial anchor of 630. Physical space is now represented by an abstract integer, allowing it to interact algebraically with the linguistic scalars. To connect these domains, the lattice employs discrete difference operators, fixed mathematical steps that bridge different datasets. Two primary step operators dictate the movement across the system: modulo 33 and modulo 72. Applying a modulo 72 array to the 630 spatial anchor generates a cascading sequence. At 414, it intersects a simple cipher value. At 270, it returns to the hospital's coordinate sum. And at 126, it references the 1,260 days in Revelation 12:6. These subtraction arrays function as bridges, aligning geographic data with linguistic and temporal references. All three data pillars converge at node 576. This value serves as the primary algebraic link for the entire model. The system derives this node by selecting different coordinate tokens from the anchor sites: the 211 arc-minute sum from the hospital and the 365 DMS total from the tomb. Added together, they resolve to 576. This spatial sum matches the geometric values of foundational strings, like alpha and omega, calculating to 576. The number is factorable by the base operator 72 and equals the sum of earlier physical anchors, 216 and 360. This intersection indicates that the 576 node was a targeted outcome, achieved by selecting specific numerical partitions from the source data. When we zoom out, we can see the full architecture of the lattice and how the different domains have been integrated. The system achieves closure by treating physical reality and abstract language as a series of interchangeable integers. This is made possible through coordinate partitioning and the use of the 33 and 72 stepwise arithmetic ladders. The result is a model that demonstrates John Archibald Wheeler's it-from-bit paradigm, an attempt to build a mathematically conserved structure out of disparate datasets.